All right. So this is the supplemental instruction for our Cal 1. The next section is the section 1.4, trig functions and their inverses. We just have to do like a pre-recorded video, load it, and I just have to do my best to try to answer questions remotely. Trying to be live was it just wasn't working. Like I don't know what I'm doing wrong, but it just wasn't working. So I usually always have like a backup or some kind of plan or something. So we're gonna go ahead and do our best to talk through this. This one, these slides don't really have examples, so what I'm thinking is I'll just go through these slides and then maybe work a few examples from the homework. I might just choose a few questions at random. It would be great if you all could just like ask questions from the homework. That way I can ask specific questions. Otherwise, I'll just try to choose some. I'm thinking that might work, or I might just kind of step back a little bit, but let's take a moment to look at this. So we have section 1.4 trig functions and their inverses. Okay. This one is talking about arc length. We have a circle, a radius r, and central angle theta in standard position, and this s is going to be the arc length created by a central angle of theta in standard position. So on a circle of radius r, radian measure is theta is s divided by r theta. I think when we introduced this before, we said the arc length. We said something to the effect of S equals r theta. So arc length equals r times theta, where theta has to be in radians. Okay, so that's from pre-cal. So arc length S equals r theta. Let me see what's going on over here. On a circle of radius 1, then the radian measure of theta is going to be the arc length. So if your r was 1, then S equals theta, or the arc length equals the central angle. So then we had this right triangle trigonometry. This is SOHCAHTOA. So SOHCAHTOA. Sine is opposite over hypotenuse. SOHCAHTOA. All right. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tan is opposite over adjacent. The reciprocal of tan is cotan. As you see, the reciprocal of cosine is secant, and the reciprocal of sine is cosecant. All right. So this, you should know this from pre-calculus. So I think in pre-cal we also said, so when we're working with these circles where the center is at the origin, we said that the positive rotation is going counterclockwise and the negative rotation is going clockwise. So given any point on the circle, the x comma y, so you have your x and your y, so you can make a right triangle at any point on the circle. And the radius, if this is x and this is y, and it makes a right triangle, then the radius is going to be the square root of x squared plus y squared from Pythagorean theorem. Okay, I can't think of anything else there. So let p of x be any point on the circle. Then we said the sine of theta, so where theta is the reference angle. No, theta, but it's in regards to the reference angle. So you can, even though theta is over here, you can consider the reference angle here. All right. So if we said sine of this angle here, this reference angle will be opposite over hypotenuse, so then y over r. You see it here. Cosine would be adjacent over hypotenuse, so that would be x over r. So on and so on. All right. But, to visualize it, we use the reference angle, but otherwise it's really sine of the theta. This is the unit circle. The way I remember the unit circle, so if I focus just on quadrant 1, right? 60 degrees, 45, and 30, these 3 points. Notice that all of these denominators are 2. 2, 2, 2, so on and so on. And then we go 1, 2, 3, 1, 2, 3. And that's how I get these 3 here. This one's a little bit out of place. This one's actually supposed to be over here. Actually, I'm going to go ahead and just move it. Let's actually go like this a little bit further. Copy the image, and I think we can paste the image. Put it where it needs to be. And then let's copy, paste. Okay, I think that's almost there. Nope. Okay, yeah. So I just went on and readjusted it. But all the denominators here are 2, and then it just goes 1, 2, 3, 1, 2, 3. And we take the square root of all the numerators. So whenever the reference angle is 30 degrees, this is our x, this is our y. And then we have to straighten out the plus and the minus based on the quadrant. I know because I'm not able to get the feedback going back and forth with the students. I would actually have a bunch of questions here, but it's just gonna have to be. It is what it is for right now. Let's see this one. So if theta was what 8 pi over 3. So what is that? 2 2 2/3. So 2 pi will put us back. Will put us back at the start, and then 2/3, 2 pi over 3. Let me think about it. I mean, you could convert it to degrees. I don't know. So 2 pi over 3. If you said times what 180 over pi, 6 to 120, right? So that's 120 degrees. So then that the reference angle, if we say pi minus or 180 minus 120 is 60. Yeah, that's a 60 degree. So then 1, 2, 3, 1, 2, 3. Yeah, it's the same as the 60 degree in quadrant 1. But we have to straighten out the x and y to make sure that the signs are proper. Now I know I'm not really writing much here, but yeah, let's kind of let that be for now. If anything is not clear, just reach out to me and I'll go back and you know, slow it down and focus and actually write everything out. But it's just because of the way things kind of worked out. It's kind of coming out this way. Let that be one. So I think, these trig identities, we have reciprocal identities, Pythagorean identities. We never talked about the double and half angle identities. I would just expect you to know how to use them. We're just gonna kind of those are just. I just want you to know how to use these reciprocal identities. You should know Pythagorean identities. We talked about if you took my pre-cal class before. Double and half angles. We just never made it to those. I would just expect you to know how to use them. Okay, as best you can. Let me think about this. So the function of sine is a period of 2 pi. So sine, cosine, secant, and cosecant, they repeat every 360 degrees for their domain. And then for tan and cotan, they repeat every 180. Okay, I'm going to let that be. Oh, these are the graphs of the reciprocal trig functions. So for instance, on the left, we have the graph of sine, and then the blue is the graph of cosecant. So for sine, I think we had the 5 key points, right? I think before we said that sine started at the origin, then it went up, it went from the middle to the max, middle, min, like that, and it continues that pattern in both directions forever. So then when we go to graph the reciprocal function, which is going to be cosecant in this case, the zeros turn into asymptotes. All right, so all the zeros, because when you flip a zero, it becomes undefined. And then we do u's that start close to an asymptote, pass through the max, finish close. Start close, pass through the min, finish close. Start close, pass through the max, finish close. So on and so on. That's in both directions. And then so that's the graph of sine and cosecant. And then we have cosine and secant on the left, on the right. Okay. These are the graphs of tan and cotangent. Yeah. I want to say that both of these are symmetric with respect to the origin. So they're both odd. I think that's okay, yeah. These are talking about the transformations on trig functions on the general graph of a trig, right? So usually when we do transformations, things that I've studied talked about, we usually work our way from the inside to the out, right? So let me think about it. Do I want to go in that order? Yeah, I think that I should be okay. So this is the general form of like a trig, right? If we want to identify the transformations, so notice if we subtract subtract the positive on the inside, it should go to the right. So horizontal shift by a factor of c. So this says we take the original graph, we shifted it right by a factor of c. This is our omega. This, what is this? Affects the period. So the period is going to be 2 pi over the absolute value of that b or omega. All right. So instead of repeating every 360, it's going to repeat every 360 divided by absolute value of b or absolute value of omega. All right. So that affects the period. And then if we keep working our way out, this is going to be the amplitude. So where d is the middle, or where it started, and then we have how plus a for the max and minus a for the min. This a right here, and then sorry, this d is gonna tell us vertical shifts up or down. All right, if we add a positive, it's gonna be a vertical shift up. Okay, so that's like a kind of a recap of like transformations. Let's see what else do we have. I'm not sure what they want us to do here. Sorry. Okay. So if we have y equals the sine of x and y also equals a half, so notice that the solution to the system has infinitely many solutions for where y equals half crosses the trig function sine of x. So notice in and of themselves, trig functions fail the horizontal line test because we can draw a horizontal line and it'll touch it more than once. So if we want to talk about inverse trig functions, we have to impose a restriction on the domain of trig functions so that they pass the horizontal line test. All right. So I think before, if this were sine and we wanted to talk about inverse sine, we would have to impose a restriction on the domain from negative 90 to 90. If we restrict the domain of sine from negative 90 to 90, notice my dog is like, she has a toy. She's just running around. Maybe I might try to get a video of her. It's really funny, actually. If we restrict the domain of sine from negative 90 to 90, now we have an image that will pass the horizontal line test, right? Similar with cosine. Cosine we restricted from 0 to 180, and this passes the horizontal line test. So then we can start talking about inverse trig functions and things of that nature. So if y equals the inverse sine of x, is going to be the value of y such that x equals the sine of y. So where y goes from negative 90 to 90 inclusively. Sorry about this. So the restriction on the domain we impose for sine goes from negative 90 to 90, and for cosine it goes from 0 to 180. And both of their ranges are both negative 1 to 1. So these are just kind of viewing the trig functions and the inverses. Same here. This is just right triangle trigonometry. It says sine of theta equals 2/5. Oh, yeah, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tan is opposite over adjacent. All right, so I'm going to let that be. This one's similar. So again, this comes out of SOHCAHTOA. What's that? Oh, we're not actually far off. What's the time? I see the clock. She's crazy. What is that? Phi? Let's see. Oh, this is talking about a function, a trig function given its and its inverse and how they relate. I want to work an example. I'm just gonna let that be for right now. And I think this is more restricted domain, range of the tan, range of tan. Oh, so for cotan, yeah, these are just talking about the trig functions with their restrictions. So I think like the previous one was tan, right? So we restricted tan from negative 90 to 90 exclusive, or the open interval from negative 90 to 90. So because it's undefined at negative 90 and 90, and then the range of tan should be all reals. So there's the domain. So the domain of the original trig function is going to be the range of the inverse, and so on and so on. All right, and vice versa. And this is for cotan. So cotan we restricted from 0 to 180, the open interval from 0 to 180. So if that's the domain that we impose on what is that, cotan, then that's going to be the range of inverse cotan. So the domain of the original is the range of the inverse. Secant. Oh, yeah, this is a similar discussion for secant and cosecant. Okay. So I'm going to load this. I really just want to be available for homework questions. Like, I think what's best is if you all go through the homework. If it's not clicking, just email me and I will walk through any of the homework questions. Okay, I think that's the best thing. I know that I didn't really like these notes because but I've noticed that a lot of them don't really have a lot of examples. They just have figures because I pulled from at least two or three different sources, and they all were kind of doing that thing. Um, but so I think the best way to kind of see this is to kind of go through the homework. I'm going to leave that for you to do. If it's still kind of giving you a hard time, just make use of the Ask My Instructor on Pearson. Also, let's kind of just be ready for exam one over chapter one. It's not is this most of chapter one should be a review from college algebra and from pre-cal. You just have to do the best you can. I'm trying to keep it light in lieu of being forced to go online and things of that nature because I know that's an added challenge to something that's already kind of difficult. So just I'll do my best to kind of work with you and work it out. But just be in contact, email me, reach out if you're not able to get it, or and we'll take our time. Okay. But with that, we're going to end the session here, and from one beautiful mind to another, enjoy the rest of your day.